just going to get started, keep it kind of short and sweet. So basically, we are LI.FI, and we are basically a liquidity bridge swap aggregator. So basically, all our smart contracts really do is take existing bridges, DEXs, and then use some routing logic in our backend to basically give users the best swap or bridging route possible to bridge to over 30 different chains. And the way our contract is laid out is we use the EIP 2535 diamond standard. So our contract has one main entry point. It's this LIFI diamond.sol in the source directory, and then what the functionality we add to our contract is provided by facets in the facet directory. So the way a user usually interacts with our contract is they'll go to a UI like jumper.exchange, say they want to bridge from Ethereum to Blast, for example, and they'll just choose the token they want to start with and the token they want to end up with, and then our API will just give them a route, and the route will essentially just be call data that is passed directly to our contract and run that way. So yeah, let me go through this a little bit. So everything will go through the diamond contract, as I just said. And then for the various different bridges and DEXs that we use, we have very specific facets or contracts, and these are all called through delegate calls. So for example, we have hop, we have a specific hop facet. Let me just click on it for a second. And then every one of these facets has a very similar structure. So we can either bridge through the protocol that we're integrating directly. So essentially, the user sends their tokens to us, and then we send those tokens straight to Hop in this case. Or say, in order to get the best route for whatever token they want to end up with, we determined that they should probably do a DEX swap on the source chain. So we have a function that would be called that would basically swap their tokens before bridging through the protocol. So let me show you what that looks like. So every protocol we integrate usually has something like start bridge tokens via whatever the name of the protocol is. So in this case, Hop. And then in the case that I talked about, where we would need to swap on the source chain, we have this swap and start bridge tokens via Hop. And this takes an extra, basically an array of what we call swap data, and it just tells our contract what needs to be swapped, where it needs to be swapped, what approvals need to be made, etc. So there's that. That's for basically the facets that are for integrating different protocols, and then we have some utility facets that give our diamond some different functionality or allow us to do some sort of configuration. So we call these the core facets. And so we have an access manager facet. I'm not going to go into detail for all these different facets, but we have like an access manager facet, and it allows us to basically, if we really want to give some sort of access to different functions or different calls to a wallet other than the owner of the diamond, We're actually looking to phase this out because we don't really use it, but it's there. Uh, we have we have a call data verification facet. So we have a lot of people that integrate us uh, directly through their own smart contracts. And so they want to be able to ensure that whatever call data that they're about to send to us is valid call data, and they can basically verify it through this facet here. Um, One other important one is we have this periphery registry facet. So in addition to the facets that basically add functionality to our diamond contract, we have different periphery facets that are not part of the diamond contract. And these allow us to do a bunch of different things like collect fees. Um, on the destination side, when a user is receiving a token on a new chain, we can allow for things like destination calls. So when the tokens arrive on the next chain, we can do some swaps there or some zaps, what have you, do some arbitrary call data magic. So those are in the periphery facets, but we register those, not that our contract, the diamond contract itself really needs to know about it, but more so that it's just a convenient place for our back end and other code to be able to query, hey, what's the periphery contract address for X, for example. So we register those things in this periphery registry facet, and that's simply a key value store. Let's go into the periphery real quick. So we have these periphery contracts, and like I said, they allow us to do different things outside of the diamond. Our diamond is not meant to hold or lock anybody's funds. Basically, it's designed so that when a user sends funds to our contract, we immediately forward it on to the next step. We don't want to keep any funds. We don't lock any funds on purpose. With that said, our contract does sometimes collect dust through different contracts depending on what's happening with various contracts. And we've already mentioned that in our as part of the contest, like that's expected behavior, so we don't really count that as an issue. But um, yeah, so we like to keep all of the complex logic that could potentially leave more dust or lock user funds outside of our diamond, to keep it from being such a huge target. So we have like fee collectors, we have our own DEX aggregator, similar to something like 1inch or Sushi, with our own aggregation logic that we sometimes use. And then we have these different receivers. So a lot of times these protocols allow you to bridge funds to a destination chain and then specify that, hey, I want to do a swap immediately on receipt. So these receivers are designed for the specific protocol. So here we have a receiver specifically for Across version 3, and then one for Stargate version 2. And these just match the selectors that those protocols expect. And they allow us to do swaps and arbitrary call data type stuff. We have a token wrapper, which is just a kind of utility for wrapping and unwrapping native tokens like WETH or wrapped BNB, for example. An executor. So these receivers don't actually execute the destination logic. We have a separate executor that does all of that stuff. Again, trying to keep things separate. We have also an ERC20 proxy. So we do things like if we need to do any approvals for certain things that could be dangerous, we approve to this, and then have privileged contracts that can pull from this. So we don't get bit by different approval exploits. So there's that. Here, I'm not going to go into detail, but we have a lot of our contracts and pull in some of these different utility libraries to avoid rewriting code. And then here we have a bunch of interfaces. Again, there's not really any business logic, and there's just interfaces that we use to interact with different protocols. Helpers is kind of unfortunately named, but these are basically some contracts that we inherit in some of our contracts to give different functionality. So we have one that gives us some utility functions for swapping, another for validation. A lot of these periphery contracts, like we said, sometimes depending on if something fails or if somebody sends tokens to our contracts for some weird reason, they're going to get stuck. So we have a way to retrieve those if need be. Let's see. These errors, it's just custom errors. So it's just a facility file full of custom errors that we reuse all over the place. That's basically the gist of our, one second. Is the sound low for everybody else? How about now? Okay, perfect. Yeah, that's basically the gist of our contract. We're essentially a wrapper for a lot of different protocols, and a lot of the brunt of our business logic is actually done through our API, and we just basically construct complex call data and send it to our daemon. I'm not sure what else to go over, but I'll be happy to answer any like specific questions if people have them. Yes, confusion. We are basically a wrapper for a bunch of bridges, also DEXs. Yeah. So as far as anything specific, uh, we, I mean, one thing we really would like to find out, or we really would like people to look for, is any way for arbitrary calls to be made. We have a lot of safeguards in place. Basically, when it comes to like things like swapping, we have basically an allow list where we only swap for certain DEXs that we trust. This prevents things like people calling, basically calling like ERC20 tokens, for example, as a swap call, and then like pulling anybody's tokens that are approved to our contract. I mean, we've been bitten by this in the past, not intentionally, but I mean, that's the reason we have these DEX safeguards. And we really would like anybody to basically check to make sure we don't have any of those anymore. I mean, we've tried our best to get rid of that kind of stuff, but I mean, yeah, that's basically the purpose of doing contests like this, is to get more eyes on this. Any other questions? All right, thank you everybody, and happy hunting.